Okay, so you're welcome to this lecture, and we're going to look at structures, unions, and typedefs in C. So it's important that as we approach this lecture, we need to understand that this is one of the very important facility when you're writing programs in C. So I'm going to ask you to read um, these two this this chapter in these two books. I'm going to share with you Diatel and Diatel. You have to read chapter 10 about structures, unions, and typedefs. And then, of course, you'll find also another book by Kanigan and Ritchie. You read chapter 6 to appreciate what structures, unions, and typedefs are. So it is important. It's a reading assignment which you should be able to read. I'll share with you Diatel and Diatel. You have to read Kangan and Ritchie. Okay. When we talk about structures and unions, these are major language facility in C that we can be able to introduce in our course so far. So they are essential for building up interesting data structures. When we talk about interesting, something that can be literally very dynamic. So we're talking about essential data structures. How do we build them up? For instance, data structures of multiple values of different kinds. Maybe you have a data structure that has integers, that has characters, that has strings. Just one structure can be able to contain many other kinds of data. Two, looking at data structures of indeterminate size, structure that is going to have big size, okay, which you cannot just determine this. For instance, if you're talking about a university intake, that can be a very big data structure. You don't know how many students are going to be admitted in the next semester. So if you're creating a data structure, that can be literally huge. So it's important for you to know that data structures are very key when you're programming with C. These are one of the advanced topics in C. So by definition, a data structure is a collection of one or more variables, typically of different types, but they are grouped together under a single name for convenience or convenient handling. Okay, so looking at a collection of one or more variables in one place. They are typical of different types, but they are all grouped together under a single name for purpose of convenience of how to access them. This is what we know as a struct in C or in C++. So a struct is actually that collection of number of variables. So this struct can be like a class you have programmed with Java, but it has no methods. That means just a simple class or an abstract class. And in C++, a struct is a class also with no methods. So either way, we can now relate. A struct defines a new type, that's to say a new kind of data type that a compiler regards as a unit. For instance, we can have a struct or a structure called motor, and then we can have different variables like maybe volts, type float can have amperes, type float can have phases of type integer, maybe also rotational speed of the motor, which can also be a float. So literally that can be a structure. So we create a structure using the keyword struct, and then we give it a name, motor, and then be able to open, close, and put a semicolon at the end. So all these are data variables that we have initialized or declared inside this structure called motor. So the motor is the name of our structure, and you have to note that the name of a type is optional if you are just declaring a single structure. Okay, and these are members of the structure, the variable that we have declared in there. So a member of a structure is an analogous to a field of a class in Java, as I said earlier. So when declaring structure variables, you can declare them on one line using the keyword struct, then you say motor, p, r, and q. All those are variables under the name of motor, part of type structure. This will declare those variables under struct motor. But also you can be able to declare an element array of a structure motor, just saying struct motor, maybe m, square brackets, and then the number of characters that can be carried to allocate 25 units of storage, each of which is big enough to hold the data of one of one motor. Then you can also use a pointer. We have talked about pointers. So this will declare a pointer to an object of type structure motor. So when you're accessing members of a structure, for instance, say we have structure motor P, then structure motor Q, which is an array, then you can be able to access using the object P that is created by the structure motor, which is p.volts, p.amp, p.phases, p.hours. So P is an object that we are using to call the members or the variables inside our structure we called motor. Okay. So I've added another QI element of Q. This is an array. Volts is the voltage of the ith motor, and this is the speed of the ith motor. Okay, so you can be able to access elements that way. So it's like in Java, as we call objects. So for using a pointer where you have a structure called motor and having a pointer, then you have to say to put the pointer inside the bracket, then the name of the variable in the structure, which we'll call the variable that, and also do that as it is shown. So somebody would ask why the parenthesis. It's because this is a pointer, okay? Because the dot operator has a high precedence than the unary star operator. So this is a pointer, and then which is pointing to P. So we need to use this so that it can have a high precedence of calling this variable. The reason is really you really want to express something like that, okay, to mean what you think it should mean really. So the pointer operator notation is a nuisance literally because it's clumsy to the type that we're using, but also you need to match it. So too many keystrokes can be involved. This construct is so widely used that the special notation was invented. For instance, you just use this notation pointing to the member that you're trying to raise, where P is the pointer to the structure that you're trying to call. So instead of using this notation here, it is better you use this notation if you're using a pointer to point to a structure. Of course, that is ambiguous in C and C++. It's quite very ambiguous. So that's why as we develop to more object-oriented, we find that it is easier in languages like Java and others. When we look at our previous example, we have a structure motor, which is a pointer. So we can be able to point to volts that way or to phases that way. So then we're able to get our results. We're able to get the results. Yeah, so okay, so that's very important that I was talking about. If you're using a pointer, it's better to use this part of a pointer just to avoid ambiguities or complexities when you're pointing to a structure. So what are the copy operations on or the operations on a structure? We have the copy or the assign operation, where if you have the structure, as we said, P motor that is having members P and Q, then you can be able to assign the value of P to Q. You get the address, the structure of motor P, and then you assign it to the pointer S. Then we can be able to assign the pointer S to a value of pointer P. You can also access the members using p.volts or the pointers as S pointing to the amps. But you have to remember that passing an argument by value in an instance of copying or assignment. So if you're passing a return value for from a function, the caller is an instance of copying or assigning that value. Okay, so literally, you need to understand that passing an argument by value is actually an instance. You are literally copying or assigning that value. An example, if we have a structure motor called F and we want to copy the value of G, we'll be able to copy H, assign it to G, then we can be able to return H. So H will have taken over the value of G in that aspect. If you are assigning to a structure, if the large structure is to be passed to a function, it is generally more efficient to pass a pointer than to copy the whole structure. Remember, the structure can be very big, and in memory it will be very hard to find all the details. So we just get a pointer to that value and we're able to get that. Though I would disagree with that, because copying is very fast on modern computers, or creating an object with malloc function and assigning a pointer is not as fast as well, especially if you want the object passed or returned by the value in real life situations. It is a judgment call, as I would say. How do we initialize the structure? Initialize the structure using the keyword struct and then the name of the structure, which is which is motor. Then we can be able to open the bracket, close the bracket, and then put a semicolon at the end of the last bracket. But we can be able to initialize members there of different types. So we have the float and we have an integer here. So we have a volt of type float, an amp is of type float, and RPM is also of type float. But phase is of type integer. So it can be able to hold data of different kinds. So also you can be able to set an array to it. So if you have a structure called M of motor M, we can be able to assign different values, putting them in brackets. If they are numbers, you don't need to put them in quotes. If they are characters, then you put them in quotes. Okay, that will initialize a new structure. Okay. So I told you to read Callaghan and Ritchie. You'll be able to appreciate what he talks about in this topic. Okay, so why do we need structures? Of course, this is an open-ended data structure. That means it can be as big as you want. So structures that may grow during processing. But also you need to avoid the need for the realloc function and a lot of copying. So self-referential data structures like lists, trees, etc. are better off. Okay. An example, if you have a structure item and you have a pointer type character S, pointer S is type character, then you can also have another structure item getting another pointer next that aspect. So that is legal if you're doing that. And that is to say, an item can point to another item, which can also point to another item in return, which can point to yet another item. So you can be able to have one pointing to another, pointing to another point, as much as you would want. Okay. So thereby this form a type of list of items which points to one to another. Okay. This item 1 pointing or node 1 pointing to node 2, node 2 pointing to node 3 in that aspect as the number of list grows. Okay, this is just to literally understand what a structure does, and as if you're looking at using the typedef, typedef is a way of renaming a type. You need to look at either in Diatel or in Kalgan and Richie, understand much better what our typedef is. But if we have a structure already we created called motor, we can be able to change the type by calling it motor. So we can have motor mn and motor, uh, which is a pointer and an array, and we can have motor as a function in that aspect. Have that, then you can also be able um, to rename any type, which provides convenience in naming, but also clarifies the purpose of the type. It makes also cleaner your code, and your code becomes more readable. It also supports portability across different platforms as you work. For instance, if you say typedef, then have a string of characters, or typedef int size t, or long int 32, or long int 64, or whatever you're trying to do. So these three may change from platform to platform. They're defined once in a header file, but they can be able to be changed if you're working on different platforms. You can work on 32-bit or a 64-bit, whatever system you're working on, it will change, but literally you have just written it once in a header file. This is very common in C and C++, especially for portable codes that we want to port. If we are to revisit our structure and the pointers that we did before, typedef structure item can create item, and then have item a pointer p and pointer q. Then we can have structure item having character a pointer info, item next item as a pointer as well. So if you have questions about this, I'm going to ask you to just send them through, and I'll be happy to answer concerning structures and pointers. Okay. But when we look at unions, a union is like a structure as well, but only one of its members is stored, not all of them. For instance, if a single variable may hold different types of data or different time at different times, and the storage is enough to hold large numbers or large members as you may have them. So the members are overlaid on the top of each other in that aspect. So you have union, and then you have int ival, float fval, and then character sval as a pointer. Then you're closing it with another member here outside as you. So it is the programmer's responsibility to keep track of which type is stored in a union at any given time. So please make sure that you read about unions as well in those chapters I've told you, chapter 10 in that Ditel and Ditel, and of chapter 6 in Ricci and Kangan. So the members of a structures are enumerator and the union. So we created an enumerator here, and then we created also a union here. So these are two members of this structure called tagged item. So the value of tag says which member of you are you going to use. So unions are used much less frequently than structures mostly in their inner details of operating systems and in device drivers. In embedded systems as well, where you have to access registers that are defined by the hardware. So they are majorly less frequently used than structures, but they are majorly used in the inner details of an operating system. And of course, we talk about the inner details of the kernel, which is the core of the operating system. And of course, in the device drivers, okay? And of course, in embedded systems where you have to access registers that are defined by the hardware directly. Also, if you have questions around this, please email them to me. Okay. So I just want to bring this lecture to a close. Okay.